Hello viewers, today we are going to see about advantages and limitations of frequency modulation. This question has appeared recently in the model test of class 12 physics. First we will see advantages of frequency modulation. The very first point is noise. There is a very much decrease in noise as when compared to AM. AM means amplitude modulation. Okay. Since the noise has considerably decreased, the signal to noise ratio value has increased. This is the greatest advantage of frequency modulation. The second point is efficiency is very high because the information is in the frequency components. So you know the definition. The frequency of the carrier changes in accordance with the intensity of the signal. It's called frequency modulation. Noise generally affects only the amplitude, not the frequency. Therefore, noise cannot affect frequency. And in FM, all the information is carried in the frequency components. Therefore, the efficiency is very high. There is no loss of information. The entire audible response, that is 20 Hz to 20 kHz, can be easily covered with frequency modulation without any disturbance. So that's why efficiency is very high. Third point is FM has better quality compared to AM. Yes, because AM means amplitude modulation. That means if the amplitude of the carrier changes in accordance with the intensity of the signal is called amplitude modulation. Okay. Here, as I already told you, the noise affects only the amplitude, not the frequency or time period. Time. Therefore, AM is affected by noise. The amplitude gets affected. Whereas in FM, the information is hidden in frequency domain. Therefore, the quality of signal in FM is very high. That's why FM has better quality compared to AM. So these are all some of the advantages of FM. Now we will see the limitations of FM. FM needs a wide bandwidth. Wide bandwidth in the sense, if you look into the commercial FM starts from 88 to 108 megahertz in India. 88 megahertz to 108. The bandwidth required for this commercial FM to be transmitted, suppose if the center frequency is 94.3 megahertz, then upper side this 94.3 megahertz plus, that is 94.3 megahertz plus 75 kilohertz upper side. In the lower side, the deviation from the center frequency will be 94.3 megahertz minus 75 kilohertz. So that means the bandwidth required to operate one channel in this 88 to 108 megahertz is 150 kilohertz. The remaining 50 kilohertz, so this is the remaining 50 kilohertz, it is utilized for to separate the channels. We call it as guard band. So this is 150 kilohertz. This guard band is 25 kilohertz and this side it is 25 kilohertz. So put together totally it occupies 200 kilohertz as the bandwidth. So that means it needs wide bandwidth. If you consider AM modulation, Even if you go for the highest frequency, say 20 kilohertz, then twice the 20 kilohertz is 40 kilohertz. That means you can operate 5 channels, whereas in FM you can operate only one channel. But if you consider voice frequency and frequency is less than 10 kilohertz, then in that case you can operate more than 15 channels without any problem in the case of AM. Because of this wide bandwidth, the number of channels is very limited in the case of FM, whereas with the same bandwidth you can operate 10 to 15 channels in amplitude modulation. That is one limitation. Also, the AM circuit, transmitter circuit and receiver circuit is very simple. Whereas in FM, the transmitter and the receiver circuits and the method of receiving the signals is complex. So that is another limitation. And one important point we have to remember is, while receiving the frequency modulated signal, the frequency variations is converted into amplitude variations. That means it is converted into amplitude variation and then only we are going to detect. That is a slope detector, like that. So frequency modulation is converted into amplitude modulation and then only it is detected in the receiving end. So that's why FM transmitter and receiver circuits and systems, everything is complex. Then if you check out for the area of coverage, FM signals can maximum go up to 70 to 80 kilometers, provided there is no hindrance. Whereas in amplitude modulation, we can go up to 1000 kilometers. The only drawback with amplitude modulation is the signal is affected by noise, whereas you get a very good quality in frequency modulation. So that's the answer for this question. Hope you have understood the concepts behind advantages and limitations of FM. Thanks for watching this video. Nandri.